Taste of Elixir. So this talk is meant for really people that are curious about Elixir, that may be coming from another language and are, they hear about Elixir. They see that it ranks highly on Stack Overflow surveys every single year. They see that like Hacker News articles get upvoted a lot. But if Elixir is so popular, where are the people that are using it? I come at this problem from several different directions, but one of the kind of conclusions I have is that while the power of Elixir is certainly there, and the case studies are out there in terms of demonstrating its power, we don't do a good job of really kind of giving like a primer on basic concepts in Elixir that carry forward into the more complex projects. So this talk is going to be like just very basic, going over some of the stuff you've seen probably more about Elixir, which is like pipe operators, pattern matching, and getting into like the really nuts and bolts of what differentiates Elixir as a language apart from other languages. But first, who am I? So I'm the founder and CEO of Dockyard. We're an Elixir consultancy. We have been an Elixir consultancy since 2014. The company's been around since 2010. And we were the primary sponsor of the Phoenix framework for a bunch of years. Chris McCord worked at Dockyard. We helped get the NX project, which is the machine learning project in Elixir, off the ground, and we sponsored a lot of that work for a bunch of years. LiveView, which you probably have heard of, is client-side framework built for Phoenix applications that was created at Dockyard, and I am the lead dev on a project called LiveView Native. And why am I here? Because back in October, I opened my big mouth. I pointed out that there were no Elixir talks at LambdaConf, and the conference said, well, you should come and do one. So I came and did one. But that was about like 3 months after I did the tweet, the original tweet. Not sure why it took so long to get the response. All right, so when I think about Elixir, I keep coming back to this phrase that it's simply powerful. It's incredibly powerful in its implementation and in its architectural design. When you build applications correctly in Elixir, they can scale almost infinitely. Performance is top-notch. Furthermore, as we're going to see a little bit later in the talk, it brings down like operational costs of building out your application and maintaining it and continuing to extend it over time. And it's also a very simple language, in my mind at least. This is helped in part through functional programming in general. I tend to think that FP in many ways can be more simple than object-oriented programming, but also the way that it is thought through as a language gives it more simplicity. So, kind of the buzzword, dynamic functional programming language. It's built on top of the Erlang virtual machine. So I'm going to be referring to the Beam or Erlang for this talk a little bit. That is, like, Elixir is just syntactical. Like, it's a syntactical language built on top that runs and compiles down to Erlang bytecode and runs all the application code on the Beam or the virtual machine. It is a language that's heavily focused on concurrency. It has multiple use case for it. So I think when a lot of people hear about Elixir, they think, oh, it's a language for building web applications, but it's much, much more than that. Its guts being Erlang has a history in telephony. While Phoenix, the web framework, is like the killer app, so to speak, in Elixir, there's machine learning effort. There is an embedded software systems effort. There's data science. There's people that have done like graphics type games. I'm involved with the effort to bring a lot of these things over to native application development as well. And this is probably my favorite part. I think we are unfortunately slipping further and further into a world where the big fangs effectively control our tech stacks more and more. And Elixir is one of the few kind of alternatives that are out there that it is community driven, and so anybody can really kind of jump into the conversation and help drive its future. If you have a good use case and if you can defend that use case, you can push it forward. I think you'll be really surprised at how accessible many of the people are. Right there, Paulo, he's one of the leads on the machine learning project in Elixir, and everyone is just super friendly in the language ecosystem. But what it kind of has its like history of is the creator of the language, Jose Valim, was on the Ruby on Rails core team, and he was tasked with solving concurrency in Rails. And after spending some time looking into it, he came, at least at the time, came away with the conclusion that because of Ruby, there really wasn't a path forward on solving concurrency in the ways that he wanted to solve it. So in many ways, he created his own language that has a lot of the, I'd say, traits of Ruby. It has a very Ruby-like look to it, but under the hood, it's all Erlang. So what I like to say is that the syntax in Elixir, skin deep, all the stuff that really is going to matter to your company, to your application, is all the below the surface. So what we have here, we're going to be going over are lightweight processes, the introduction to fault-tolerant design, a little bit of metaprogramming. I don't recall if I dropped that slide or not. We'll see, but at least I'll talk about it. And a rich ecosystem with powerful libraries. So this last one I'll just talk about real quick first, is that many of the projects, many of the libraries that exist in Elixir are projects that otherwise in another tech ecosystem or another technology stack are going to cost millions and tens of millions of dollars to actually re-implement. And I'm not underselling that. These are projects that are able to be pulled off the shelf that you can use for free. There's a counterbalance there. We have kind of a bad reputation, I think, in Elixir, where if you have beginners coming in and they're more accustomed to like the basic stuff being available to pull off the shelf and use, and more often than not, they get a response of, oh, you don't need a library for that. You can just roll your own Elixir, because Elixir is that simple. And in many cases, they're technically correct, but that's not what a beginner wants to hear. And so I think what we're starting to see in the past year is the community is acknowledging this issue, and they're starting to actually focus on the upfront, like things that are not technically super complicated, but are absolutely necessary to get a project going. Recently, the Phoenix framework adopted Daisy UI as its default UI implementation, component level implementation. There are several different component libraries that are coming out for Phoenix now. There's a library called Igniter, which helps to kind of create like really smooth and easy to reason about installation steps, so you don't have to do configuring. It'll do all the configuring for you. Ash is a low-code solution that is actually built by the same guy that built Igniter. So it's weird. Like Elixir solved like all like the really, 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 really hard problems for us, and now we're kind of working our way back toward the easy problems. So the benefits. So lower infrastructure costs. And this is going to be proven time and time again through multiple case studies that are out there in Elixir. Elixir just costs less money overall to build your applications in than any other tech stack that's out there. And the reason for that is because it usually requires significantly smaller teams to do the same amount of work or more work. This comes into a faster time to market. You can scale without any of the complexity, so you don't need this, to rely upon this like really kind of like, I'd say diverse tech stack of different tools you're bringing in to achieve the scalability, even for like a medium market application. Scalability is built into the language. Chris McCord, the creator of Phoenix, he left Dockyard a few years ago and he went to go work at Fly.io. If you're unfamiliar with Fly, they're a platform as a service, but their primary offering was originally around Elixir. And so what he was solving there was, push button deploys, automatic global distribution of your Phoenix applications. As a producer of Phoenix applications, I have to do like two lines of work, and I can actually distribute my application globally, and it's immediately available. The reason why you require, so actually let me back up on the reason why, because it's more of an opinion. I'll tell a story. So the kind of go-to case study in this space is Bleacher Report. Bleacher Report was one of the first real success stories of a production Phoenix application. And I'm going to not recall the exact numbers, but it's kind of like in this vicinity, where they had something like 15 to 20, I believe, Rails application servers up and running, and they had a medium-sized team. They adopted Phoenix, they refactored the entire application in it, and the reason why they did that was because in the world of sports reporting, it's pretty much a given that all the other sports news applications are just sending you the same stories, right? You know, so-and-so is on the injured reserve list. So-and-so got traded. But it's really a matter of who gets that information in front of your eyeballs first. And Bleacher Report was falling behind in terms of like its push notifications because its system was just slower. So they were one of the last to get its push notifications out when a news item was going out to all of their subscribers. They refactored in Phoenix. They were able to reduce all their application servers down to just 2, have higher scalability, better reliability. The only reason they went with 2 application servers is because they just wanted one as backup for redundancy. And I believe they reduced their team down to 25% of people than what it previously was. On top of that, they were now the first ones to get the notifications out. And so you have this, amazing, amazing kind of outcomes when companies move over to Elixir. And so we're really kind of incentivized to tell this story more and more often to people that may be interested in checking it out. All right, so let's see some basic code. I think that Prezi is going to mess with me and like reset my presentation. So what I'm going to do is I'm going to, I think I'm on this one. I'm just going to set my starting point here so I can come back to it. All right, so this is Livebook. This is a like Elixir version of Jupyter Notebook, if you're familiar with Jupyter for Python. And so here's some basic types. We're not going to spend too much time on these. Strings, ints, floats, tuples might be familiar to you, but any values can go inside the tuples. They can be any number of elements, lists, and maps. Modules, so Elixir being a functional programming language, we don't have instances when it's not object-oriented language. You call everything off of functions are scoped to a particular module, and then you just pass in whatever you want into the function, get your result. Structs are a way to kind of simulate like an instance of something. They're really just a map that has a hidden key to indicate what module it originated from. But what I have here demonstrating is the beginning of pattern matching. So in this function signature, it's not really type safety. Like it can give you like the notes of type safety, but this is at least just saying what I pass into this function needs to be of this type module. And because we're inside the module, it can't reflect upon itself until it's compiled. So we use this compile time, I'd say placeholder module to refer to itself. And then down here, I create a new struct of type car, pass it into car, and I get my car. Pattern matching is where some of the real kind of power comes about. So what I'll show here, comment this out, is basic. So pattern matching is really just the left-hand side has to match the right-hand side. So this will be fine, but if I were to try 2 here, of course, match error. We can also pattern match into any types. So here we have a tuple on the right-hand side. We have the atom OK and then the Boolean true. And on the left-hand side, I'm pattern matching because it has the same shape as the right-hand side. The OK atom is matching. And then because I'm using a variable here, it's not assignment, it shows equality. I'm basically showing that the left-hand side is equal to the right-hand side. In order to make that true, it has to assign the value to bool. So we get true in this case. And you can go to any level of depth in the pattern matching. So here's kind of like an arbitrary crazy depth of something. But again, as long as the left-hand side matches the right-hand side, we're going to have a match here. So this matches B right here matches this 1. In fact, if I were to do something like, oops, I'll cut this out here. And I will say, put an extra one there. I'll put B right here. So now this is going to match to whatever that member of that was the third nested list in there. So when you get like very complex and deeply nested things, you can, as long as you're destructuring properly in your matching side, you can match against anything. And then here is a bit about like where matching gets used quite a bit. This is a case statement. So in a case statement, we pass it a value. In this case, it's going to be this tuple with an atom in a list. And on the left-hand side, we have an example of a non-matching clause. So because the atom foo does not match foo, this doesn't get hit. So we end up with this right here, where it just reverses this. But if I were to go foo and just say, let's see, match on list. I'll do other list. So it skips the first one and matches on the second one. The matching always goes from top to bottom. Pipes. So these type of like assignments, or the variables, and then you're kind of going step, 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 is common. You may see this gets pretty ugly in code where you're trying to combine everything into one, but it's still the same value. What we end up using in Elixir quite a bit, and I believe this was, oops, stop popping up. All right, our pipes. So in this case, I'm going to take the initial value and I'm going to use the pipe operator. I'm going to pipe it into, as the first argument, into this function here. And then the result of that will now get piped in as the first argument on this function. And this is just a map. I'm going to cheat a little bit and just make this a little bit shorter. So this is because it takes one argument, and each argument, each member of that list is coming off of it. I can just give it a function reference. Oh, yes, thank you. Okay, so, pretty simple concepts, right? And then down here, we can show pattern matching within function signatures. So here's like a common thing. You pass in a value, and then you're going to use an if statement within it, right? And so this is just going to show, sorry, we're closed because this is false. But what we can do instead is we can do print sign and then actually put in the specific value. And then let's do this here. All right, so that should all still be fine, even though I have two different ways to represent the function. And so if I change the this to true, it is going to match the first one. Okay, and then next is recursion. And again, this is like, I'm glossing over quite a bit here because I want to get to like the more interesting parts. But in a functional programming language like Elixir, you're going to have to get accustomed to using recursion. And this here just allows me to take this string, and then I'm basically shifting all the characters by 5. And we iterate over this string and then recursively call the function on the next remaining part of the string. All right, now the last part before I get back to the slides are processes. And so everything else there, those are like syntactical language feature type stuff. This is now getting into kind of like the part where Elixir is set apart from other languages. And in Elixir, really because of Erlang, because of the beam, you have this virtual machine that manages its own processes. And here, what this is demonstrating is I'm sending a message to self as just its own process in this case. And it's very simple. I just send to the destination, I send a message. And here I'm doing 2 sends. I'm sending a tuple, foo, bar here with text right next to it. But over here in in the receive, and this becomes a blocking event, and it waits until it receives a matching message. So in this case, I first match on bar, even though it was the second one sent. And then inside here, I receive again, because it's not a looping blocking statement. It will block until it satisfies, and then it'll continue on. So when you want to build something that is looping, you can just put it within its own recursive loop. So if I were to do this, I get hello to hello. Now, if I were to reverse this, and I were to just say message here, and then I guess I'll comment this out. Oops, oh, I know why, because this didn't match. I'll just say Adam message. All right, and so it matches. And anyway, so the processes are kind of like the primitive of how everything else that I'm going to be talking about is really built on top of.
So you'd have to call receive twice then to get that second one.
Yeah, or you could build a function that basically calls itself after the receive is satisfied, so you could recursively, go over it.
So the message doesn't get lost; it just hasn't.
Correct.
Yet, so
yeah, actually, that's a good point. So all the processes have a mailbox. The messages go into the mailbox, and they're there until you pull them out. All right, this is where I'm going to see how my slides, if I can get back to this point. Should be fine. Okay. All right, OTP. As I mentioned earlier, Erlang was meant to manage telephony networks, and so OTP has that telephony name in it. There is a great video out there called Erlang, the movie part 2, that makes fun of this. If you're interested, you should check it. So it's kind of, OTP is like Erlang's standard library to build out distributed systems. The Beam, so these are not operating system processes. They're super, super tiny, less than 1 kilobyte in size. They are almost instantly available when you spawn one. They manage their own garbage collection, which is fantastic because this is coming from prior languages. I came from Ruby on the server, and it's going from like garbage collection hell to garbage collection heaven, which is great. They've done a lot of work in the past decade to improve Ruby's garbage collection. Just at the point in which when I adopted Elixir, it was not fantastic. And then you can send messages to other processes. And that's not limited to the current virtual machine that you're running upon. You can send messages to other processes on a machine on another side of a planet. And this is where you get into distribution. You have the concept of Erlang clusters and individual nodes that can join that cluster and then talk to other nodes within that cluster. And their mailboxes are FIFO. There's going to be two primary OTP fundamental abstractions I'm going to be talking about today that we then build on top of in a little bit in the talk. The first is gen server and then supervisors. So gen servers are one of the things I think get people very tripped up when they're first, because they come in, like a lot of people, way that they learn application development on the web is they hear about LiveView and they go, I'm gonna go learn LiveView. And they start to run through the LiveView docs. And then after a few minutes, like, this is really confusing. This is really weird. Because LiveView is actually a gen server under the hood. And unless you understand gen servers, then you're gonna be kind of confused by the concepts within LiveView. And gen servers are just ways of that the Erlang processes are managing their own messages and state. So in a gen server, you have a couple different lifecycle things to be aware of. You have the init, which gets called when the gen server is being spawned, and this is how you can create the initial state for the gen server. And then there's 3 handle callbacks that you can implement based upon your needs. Handle call and handle cast are probably the 2 that you'd be using the most because they're the ones that get called when you are calling into the gen server from externally. And handle call is a blocking event. Handle cast is a non-blocking event. Handle info is also non-blocking, but it's a special handler that gets used when you are doing a direct message send from one process to another, as opposed to going through the Gen Server API. Supervisors, this is how your Elixir applications stay up and running. And this is how they also manage and handle any type of errors or anything that comes in that's unexpected. There's actually a saying in Erlang. Joe Armstrong, one of the creators of the language, he coined it, just called let it fail. And the whole kind of concept of let it fail is an acknowledgement that in software, we jump through insane hoops to try to think of every single edge case and every single conditional that could be out there that is going to go wrong. That's not possible. Like, there's always something that goes wrong, and there's always going to be something that gets introduced that you don't anticipate. What's better and what's always guaranteed to work is if you have a way to handle when your process dies or if it fails for some reason. And that's effectively what Erlang pushes forward, is that let your process die, the supervisor will just respawn it for you automatically, and then you're good to go. So in a supervisor, you think about them as trees, right? So you have an initial application supervisor, and then that supervisor can have any number of children. Those children could be workers, which are generally gen servers, or they could have other supervisors, and those supervisors, so on and so forth, can have their own subtrees. There are different strategies for restarting. Some of the more common ones are if your process dies, if your worker dies, then don't restart it. If it dies, restart just that worker, or if it dies, restart all the workers. And there may be different use cases on why you want to do that, and then you can, of course, create your own strategy as well. All right, more code. Try to fix this. Okay. All right, so what we have here is a Gen Server, implementation. And it has server right in the name. That's exactly how you should think about it. It's a server, it's running, it's waiting for an inbound request, and depending upon that type of request, it may send a response. If it's a blocking request, a call, then it's going to send a response back. If it's a non-blocking request, a cast, then it's just a fire and forget to the server. So this is a very basic Gen Server. All this is going to do is start a new one, and the state is a count value. And then every 500 milliseconds, it's going to call into itself that handle info I was referring to earlier. So we're going to send to itself the increment message every 500 milliseconds. That's going to be handled here. It's going to update its state. And then I'll have two external calls handle to get the current value and then to increment the value. And then these here are just kind of public API that are more conveniences so that you can call the get and increment values directly off of the module itself. All right, so what we're going to do here is we'll do this. So I'm going to start it, and then I'll get the value here, get the value. We can see that it continues to go up. I'm going to put back that increment. And so I'm going to just continue increment. So this will run and run and run and run and run forever, or it hits max int. I don't even know what that is in Erlang, but it's pretty high. All right, I need to comment those out because I have my gem server right here, is using a static name. And so I'm going to repurpose this and start it again, but I don't want to lose that. All right, this may actually crash the first time because I think that Gen server is active, but we'll see. It may not because I commented out those other ones. So this is demonstrating a supervisor now. So what we're going to show here is a supervisor process where my counter Gen server is one of its children. We're going to get the value, and then we're going to kill the process. And we're going to see that when we kill the process, within, it's less than, I think it's less than 10 milliseconds, but it's actually much faster than that. It'll just respawn. It knows that it died. The supervisor knows its child process died, and then it'll restart for me automatically. Okay. Yeah, so this was because I had the previous Gen server running. All right, so what I have here is, actually, let me do this here. I'm going to just do this. All right, so I can get the value. I don't need this. Well, I have that right below anyway. All right, so if I do this, all right, so we see here, it's incrementing the counter in the gen server like before. What I'm going to do now is I'm going to force the process to get killed, and then we'll see that this will just get restarted automatically. So now it's back down to its initial value because the state that I passed in, right here, the initial state was 0. If I were to start this at, let's say, 1,000, we can see that it's starting at that value. But then I just restart the process, and we can see that started over again. Okay. Let's go back to the slides. So any question on supervisors, gen servers? Yes?
Quick question on that. Is the mailbox separate from the process? So messages that were received will still be in the mailbox when the new process comes online?
No, it dies.
Okay.
Yeah, it's all part of the same process there. And there are strategies for persisting state, though. When you're restarting that init function, if, let's say, you had some sort of state that is in a database or is in, I'm not going to go over it today, but there is a data store in Erlang called ets. You could store in ets temporarily, and then if the process dies, in the init function, you could see if that cache is there, pull it out. That's your new state, or you could, if it's not there, go to the default init state. There's actually a pretty good article on fly.io specifically about doing this for live view applications. So Elixir had, in its early days, it was really impressive because the amount of tools that Jose was able to quickly kind of backfill was really impressive. And for those coming from Ruby, it's fairly familiar. Mix is kind of like the rake for Elixir, but it's significantly more complex than a rake. It's a all-purpose task runner. XUnit is a test unit implementation. Hexdocs. One of the things that's really not talked about too much is the thing I really like about Elixir is that there's just this kind of cultural aspect of it that documentation is really important, and that's enabled because writing docs in Elixir is actually super easy. We have a fairly deep documentation system called Xdocs. You can do all sorts of things to extend your documentation if you want to. Put in mermaid graphs, you can run JavaScript, you can basically make them as personalized as you want, but out of the box by default, you get like a really nice set of documentation. And I'd say that it's very rare to find an Elixir library that does not have decent documentation. On the LSP effort, this is still underway, but it's going to be huge when we finally get it. It's, Elixir being a community-driven, really like small-funded language. This is one project that has been really lacking in that space because it's really expensive to build an LSP. But there's a team dedicated to doing it now, and it's going to be, I'd say, probably one of the really missing pieces of the language is to have a solid LSP, especially for those looking to adopt. LSPs are more or less table stakes nowadays. Learning Elixir, some decent resources on Elixir Lang site, but they actually will just redirect you almost exclusively over to the Elixir hex docs. So Elixir, the language, is documented with its own documentation system. And inside Elixir's own documentation, there's all these guides, and it's fantastic and easy to learn from there. So beyond this talk, there's a bunch of new things that are coming. There's one big new thing that's coming is a type system for Elixir. And it's not like other type systems. It's called set theoretic types, and it was effectively designed and developed and invented for Elixir. It's being gradually introduced into the language, but it's kind of like this. Elixir has this concept that it doesn't want to break backwards compatibility, and this is what I was talking about earlier with its library ecosystem. So something that was built for Elixir, let's say 1.1, should work with Elixir indefinitely forever. You may get deprecation warnings in your console log, but it's going to work with Elixir. And this is something that sets Elixir apart that I think on the one hand is a huge benefit, but it's not a fantastic marketing opportunity for Elixir because people tend to like to get all rah-rah over major version releases. But as a software developer, I greatly appreciate that if I build something today, I don't have to worry about it in a few years that it's going to break because a new version of the language came out. So anyway, this new type system needs to be introduced in a way that isn't going to break backwards compatibility with the language. And so we're getting it introduced more and more gradually with every minor release. I'm not really going to talk about distributed clusters today. That's I referred to very briefly earlier. It's our version of Redis. Okay, so now on to the things that people would be using. All right, so Phoenix. Phoenix is the most popular reason why people tend to want to choose Elixir. It's a web framework, but it does a lot more than pretty much every other web framework that's out there. So it has a core focus on performance and reliability, and these all come through the parts of Elixir and OTP that I was referring to earlier. It has a real-time communication system built into it called channels. And it should be perfectly fine to scale with your company almost forever. The kind of nice thing about Elixir and the nice thing about Phoenix is that you're not going to find yourself in a few years regretting that choice. You're not going to find yourself in a few years thinking, oh, this language is not meeting the needs that we have. Where we typically see people moving away from Elixir is most likely just political or like techno-religion type stuff that someone comes in, they just want a node backend system, and so they get a node backend system. Even the Bleacher Report case study that I referred to earlier, Bleacher Report got acquired, and I think in large part because of the refactor in Phoenix, because now they were up in their subscriber rate, they became a desired acquisition opportunity, and then they got acquired, and I think it's the company that owns HBO or Max, whatever they call it now, and part of the acquisition was they got to get on their paved road of tech, and so it was like I think it's a node shop, the acquiring company, and so they just dropped a perfectly working and highly scalable application stack in favor of Node. And so this is where we find, unfortunately, at times that Elixir tends to lose ground is because of just stupid stuff like that. So the real-time communication stuff, channels, I'll be going over in a few minutes. The routing is done through a system called Plug, which is, I'll be getting to that too. It has a full test suite, so unit tests, integration tests. You can drive headless browsers all through the test suite to check out your stuff. And that's not just for like the server-side rendered UI, it's also for the live view client-side application framework. And it has a lot of big users. Apple is one of our clients, and they're using Phoenix within Apple. Discord, I put them in here. I actually don't know if they're using Phoenix or just Elixir, but their communication, I believe their communication layer is driven by Elixir. Fly, of course, Toyota, Connect, Pepsi. These are all like big name companies that have adopted Elixir and are using it with success. All right, so Plug is, I'd say it's like the real guts of what Phoenix is ultimately doing. It is a request response middleware stack, and so a request comes in, you can channel that request down through multiple plugs, mutate it as it goes, and then send a response back up. This is a common pattern that, to my knowledge, was really championed by Rack back in Ruby days. I don't know if there was another example before that. The nice thing, too, is that because Elixir is a compiled language, there are different compilation optimizations that can happen based upon I'm not going to finish this talk in 5 minutes. compilation optimizations that can happen because you can determine what environment that you're in and then compile out based upon your needs. So in development mode, you might get more developer ergonomics. In production mode, you're going to get a faster stack. So, all right, let's see plug really quick. Did my live books fail? Hold on. Should have. I'll just stop it. Okay. Open and plug server. All right, so this is gonna, the nice thing with Livebook is that I can install dependencies right in there as well. And here's an example plug. I'm going to make sure I don't have anything else running on port 4000 first. And this is just going to take a basic request and then respond back with hello world. So if I run this and I go to localhost 4000, I get hello world, right? Well, Phoenix is built around plug. And so I have here an example Phoenix application. And, whoop, that's not it. There we go. And what we have here is in the router, actually we'll start with the endpoint. Actually, I'll go to the application real quick. So inside the Phoenix application, this application is the primary application that gets run, and it's just a supervisor. And inside the supervisor, we have an endpoint. The endpoint is right here, and this is where it sets up basically all the different plugs for your application. So we have one for sockets, we have static content, we have developer stuff like live reloading, developer dashboard, and finally we have our router. And our router is in itself plug compatible, where you can set up the allowed content types or accepts headers, and basically set up all the individual routes. Not Rails C. Sorry, I've been doing Rails work recently. All right, so I'm going to stay in here because it's easier than going back and forth on that. So these are all things that Phoenix brings together in order to create its framework. So inbound requests are actually gen servers that are getting spawned. So these are individually running processes that are managing the request, so it's not blocking other requests. You have supervisors managing the entire application, anything that your application is doing, channels, pub sub, request responses. You have templates that are compiled that are built at compile time, and so they're highly optimized at runtime for responses. And everything is built around plug. So the channels concept are the live real-time communication layer for Phoenix. And Chris and his team, they did back in 2015, we're coming up on the 10-year anniversary of this, in fact, that's November 3rd, 2015. They showed that with a single application server, they were able to get up to 2 million WebSocket connections concurrently. And the only reason they go beyond that, because they just didn't want to pay for more RAM. And so it scales up insanely well, insanely high with hardware that otherwise you'd have to throw orders of magnitude at in other tech stacks. The channels implementation here, I'll go over real briefly, but what we have is, I'll just show it. So channels is an abstraction that it has WebSockets as a transport layer, but it's not tied to WebSockets. So you can do long polling, you can write your own transport layer, but basically it's a way to manage the life cycle of a real-time communication pipeline to a client. And it will manage stuff like reconnects, it will manage stuff like back connections, backing off, and then it has different ways to scope your messages to rooms within each individual channel. So here I have a basic counter. Counters seem to be my thing today. So All we are doing here, I wrote the JavaScript where it will it'll show the connected channel success message, and then it's just incrementing again and again and again and again. So this is coming over a WebSocket. To refresh it, it's a new connection, so it's not going back to the previous state. It's establishing a new state. All right, next we'll do, I believe it's live view. So if you've heard of Phoenix, you've probably heard of live view. It is growing in popularity. It's winning people over because I did a lot of client-side application development for many years. Dockyard was considered to be the largest Ember.js consultancy in the world for a while, which isn't saying a lot because Ember didn't get that big. But we grew within that space, is my point. I had this, it's not a great joke as a consultant, but I'll tell it anyway. So back with Rails, the big thing that made Rails stand apart from the other choices at the time is it kind of had this value proposition that you can get the same thing done in half the time and for half the money. And then along comes the JavaScript community, and they're building out these super complex client-side applications. And I would say, look, we can do the same application on the client for twice the time for twice the money. And it's kind of true. And so, you have massive, massive teams that are going slower as the application grows in complexity. And that's what live view is really meant to kind of address. In some ways, originally, it was we don't want to write JavaScript. But live view actually straddles both worlds. It's a server-side and a client-side framework. There are certain things that don't make sense with server-driven UI that you want to push to the client. And live view nails both very, very well. So it's built on top of channels, so it leverages channels, just an abstraction that's right there with channels. It will calculate template diffs, so you get really small updates sent back to the client. And it has event handling as well. So I will check this out to show live view. So now I built out I think because the client's trying to connect to the wrong thing now. All right, so I built out another counting demo in live view this time. So let's check that out real fast. That file doesn't exist anymore. Inside my live project, now this is the live view. It just mounts it where I'm setting the initial state. I'm sending a message 500 milliseconds after. I get the handle info. Again, it acts like a gen server. And that's what you need to understand is that we're responding with gen server type messages, and we are managing events or handling events in a gen server type way. And then you have template rendering right here. So in this case, I'm setting count to 0. Every 500 milliseconds, I increment that count by 1, and then I display the count right here. Let's do something very basic. Click equals increment, and then I'll do +1, and handle event, and payload, socket. I'll just take this. Okay, so now, and you saw it was already there. So there's live reload. When you update your code base, the client gets automatically updated. And here I have a button that I don't know if you can tell, it's not a great button, but I'm just jamming on it, and so the counter's going up faster. All right, now, so I went over some of these things already. It reduces the complexity. It's a lot easier to reason about state in one place on the server and manage that. It offers fantastic performance. It's a very small payload. In some cases, you're going to find that a live view application will load faster than a client-side application because the amount of JavaScript we're sending over the initial for the first paint is significantly smaller, and we get that initial server-side rendering anyway. So Live View Native is a project I'm involved with, and so it's a way to take the Live View concepts and port them over to native application development. And I want to be very clear, we are not rendering web views. We are not rendering HTML, we are not rendering CSS, we are rendering actual native UI. So it's really, what we've been developing is now starting to turn into something bigger than Live View, where we're going to be extracting this out as a common server-driven UI markup language with backend agnostic clients that can connect to anything. That's why I've been doing Rails recently. But it allows for bringing forward the same design concepts of Live View and bringing them to a native application. So we support anything that SwiftUI compiles to. Watch is coming out for a little bit because there's an issue with Watch. We're targeting Jetpack as well, so all Android devices in WinUI 3. Again, these are going to be rendering the native UI frameworks. So let's see that. So this is where I may end up screwing myself because I have to open up Xcode. I know. All right, so let's see here. I pre-compiled it earlier, so I hope I get a fast recompilation. If I don't, then I'll just move on because I don't want to burn too much time. Yeah, I know, this is going to be the last thing. All right, yeah, it's gonna recompile everything. All right, what I'll do is I can put out an example of this on my social if people want to see the live view compilation, but we're not going to sit here and wait 5 minutes for Xcode to compile. Wait, let's see if it's going to do a fast recompile or not. I'll give it a minute. All right, I'll move on with the remainder of the slides, and I'll come back, and if it's there, it's there. All right, so there's a lot more. I mentioned NX was the machine learning effort. Paulo actually just the other day, is it called handoff? Is that what it is? So handoff is this way to actually create, you can code split, and so you can send your machine learning code across any number of other nodes within an Elixir cluster to improve performance, something that no other language has right now. Nerves is awesome. It's this embedded software framework built in Elixir. I did these Nerves devices where like the Home Depot animatronics for Halloween. I bought those, cut the main driver board out, plugged them into a bunch of Raspberry Pis, and then I had Nerves driving them for Halloween. And so I actually had looked like what is it, Pirates of the Caribbean at my house. And then Livebook, which I've been showing off. So that's my talk. Again, if you're curious about Elixir, want to learn more, if you feel like your company can benefit from Elixir, come talk to us, Dockyard. Thank you very much.